This question gives us a data set. This isn't included in the question. I just put this in here to help us. Give us as a data set, and then they summarize things so we don't have to do a bunch of tedious calculations. They say the sum of squares regression, SSR, is 3,968.4. The sum of squares due to error is 60.835. And if you add those together, that should make the sum of squares total. Okay, and so the regression, the coefficient of determination, I should say, is the sum of squares regression divided by the sum of squares total. And that's basically saying, how much of the error is being described by the regression model divided by the total amount of error, the total amount of scatter in these data points. So you just have to plug this in for the top and then this in for the bottom. That will calculate r squared. So SSR was 3968.4, and then SST was 4029.2. You can always check yourself too if you're calculating this on your own, because SSR plus SSE should equal SST, but that isn't required for this question. So if we calculate that, that's 0.9849. Okay, so this option isn't correct. That would be like if you made a mistake and you put SSE in the numerator, I bet. So this option's out because it has the wrong coefficient of determination. Same thing with this one. Actually, there's only one that's correct, right? R squared is not 1.0153. R squared is not this one. This one has our correct R squared. I think I cut it off because I copied and pasted these questions. But this is the correct one because the coefficient of determination is the decimal form of the percentage, 0.9849. So that means 98.49% of the variation in the y values can be explained by the regression equation. So the fluctuation in the y values, there's a whole bunch of fluctuation. And 98.49% of that fluctuation could be explained by this model, okay, by this regression equation. And the other, 1.51% is something else. Like maybe it's just a natural error that comes up in the data set, or maybe it's something that can't be explained by linear regression.